The next section in trigonometric identities and equations is solving trigonometric equations using inverses. So we're going to learn some inverses and what inverses mean. So how do you verify that an equation involving the variable x is an identity is the question we're going to be answering. So we're going to evaluate inverse trigonometric functions and solve trigonometric ratios. So first we have the inverses of three trigonometric functions. So since a function must be single valued, you define the inverse function for each sine, cosine, and tangent by inverting the representative part that has the simplest, there you go, the simplest domain values. So y equals cosine theta, we have from 0 to pi, our range is -1 to 1. The inverse, remember when we do inverse functions, we trade them. So our domain is -1 to 1, and our range is 0 to pi. Same for sine, sine inverse, tangent, tangent inverse. So here are just some pictures. So the graphs on the left show the representative part of the function that's inverted, and then the graphs on the right show that inverse function. So it's just taking and inverting. You switch all your x and your y values is basically what you do when you do an inverted function. So using the unit circle, give me just a moment. That's better. Okay, so using the unit circle, what is cosine inverse of 1/2 in degrees? So what we're going to do is we're going to convert the inverse of cosine evaluated at 1/2 in degrees. So the first thing we're going to do is draw a unit circle and then mark each point on the circle with coordinate x, because cosine represents an x value of 1/2. So if we draw a unit circle, 1/2 that's positive is in quadrant 1 and quadrant 4. So these points and the origin form a 30, 60, 90 degree triangle, because if you remember, that value is 1/2 is at 60 degrees. Okay, so then what we have to do is we have to determine different places that, or the two different places, those values. So we have cosine of 30 or 60 degrees. That's from here you go, going this way. So cosine of 60 degrees is here. To get to make that value, to get this value, we have to go all the way around the circle to here, and that's a value of 300 degrees. Or you could also go backwards 60 degrees. Remember, negative direction just means go around the unit circle the opposite way. So all three of these values represent the same thing. So it's just 60 degrees. So what's cosine inverse of -1/2? Well, -1/2 would be here on our unit circle. This is -1/2 y. And down here, -1/2 y. So what are the values, the degree measures of these two? This one and this one. Well, hopefully you remember from your unit circle, or if you don't, this is 90 plus another 30. 90 plus 30 makes 120 degrees. And then this is 180 plus another 60 degrees. 0, that's 4, carry the 1, 240. So if you remember from your unit circle, those are 120 degrees or 240 degrees. Those are both, or if you went in the negative direction, that'd be 90 plus 30. So negative 120 degrees is another measure. All are good. Okay, and then go ahead and think about this one. What is sine inverse of 1/2? Go ahead and find a couple angle measures for that one. Okay, so using a calculator, what are the radian measures of all angles whose sine is -0.9? Solve using an inverse function, a calculator, and the unit circle. Okay, so using a calculator is super easy. Make sure you have it in radian mode and just put in sine -0.9, or sine inverse. -0.9, and you get -1.12. Okay, on our unit circle, or just in general, -1.12, since we're talking about sine represents y values, So where can y be negative 0.9? Well, that would be either in the first quadrant, or I mean not the first, the third quadrant, or the fourth quadrant. Those are the only places where we can have a y value of negative 0.9. So if our x value is negative, it'll be in the third quadrant. If our x value is positive, it'll be in the fourth quadrant. So in order to find these values, you have negative 1.12. That gives you your negative value. To get your positive value, so that's this way. To get your positive value, you go all the way over to pi. Remember, this is pi, and then you add another 1.12. So pi plus 1.12, which is about 4.26. So then your two equations that you can write is negative 1.12 plus 2 pi n. That just means you're in the same position however many times you go around the circle. And 4.26 plus 2 pi n. To find the inverse of tangent, we want to look at the tangent of negative 0.84. If you just plug it into your calculator, you get negative 0.7. Remember to make sure you do it in radian mode. Tangent inverse. Now, let's think about tangent. What does tangent mean? Well, tangent means sine theta over cosine theta. So in order to get a negative tangent value, what do we know? Either sine is negative and cosine's positive, or sine's positive and cosine's negative. Where are the only two places that can happen? That would be in the second quadrant and the fourth quadrant. And those are the only times that we can have negative tangent values. So you can have the negative 0.7 going from standard position, or if you want to find the second quadrant, you go from pi and then you subtract 0.7 to find out what that value is. There you go. And then the same equations, add 2 pi n, add 2 pi n. Solving a trigonometric equation. What values for theta, where theta is between 0 and 2 pi, satisfy the equation 4 cosine theta minus 1 equals cosine theta? Okay, in order to solve this one, what we need to do is get cosine theta by itself. So let's subtract this cosine theta and subtract this cosine theta, and we'll add this one to both sides. So I get 3 cosine theta equals 1. Now from here we need to get cosine by itself, so divide by 3. Cosine theta equals 1/3. And then you just plug that into your calculator to find that value. Oops, that should be a cosine, not a sock. Cosine inverse of 1/3 equals, get your decimal approximation, 1.23. Pretty easy. And solving by factoring. This one's fun. What are the values for theta that satisfy the equation 2 cosine theta sine theta plus sine theta equals 0 for values between 0 and 2 pi? So in this one, you'll notice that there's a sine in both of these. So we're going to factor out the sine theta. So sine theta times 2 cosine theta plus 1 equals 0. That's terrible writing. I apologize. Okay, now from here we need to set each one of these equal to 0. So sine theta equals 0, and we're using our zero product property. 2 cosine theta plus 1 equals 0. So 2 cosine plus 1, we need to sign for cosine, so subtract 1. So 2 cosine theta equals negative 1, divide by 2. Cosine theta equals negative 1/2. So in order to find these values, we can make a graph and look at these values where sine is 0. Well, sine is 0 at 1, negative 1, 0, and 1, 0. And where is cosine equal to negative 1/2? That's up here and down here. This is negative 1/2 square root of 3 over 2 and negative 1/2 negative square root of 3 over 2. There you go. So these values are at 0, pi, so that's this one and this one, 0 and pi. In radian measure, this is 2 pi over 3, and this one is 4 pi over 3. So those are our exact values. For energy conservation. An air conditioner cools a home when the outside temperature is above 25 degrees Celsius. During the summer, you can model the outside temperature in degrees Celsius using the function f of t equals 24 minus cosine pi over 12 t, where t is the number of hours past midnight. During what hours is the air conditioner cooling the home? So, I mean, obviously you understand that an air conditioner runs more during the daytime than at nighttime because it's hotter during the day. So there are two methods you can use to solve this. The first one is that you can graph these two equations. So you set y1 equal to 25 degrees. And then this is your y2. 24 minus, make sure you put it in parentheses, and then make this your x here. Pi over 12x. And then you graph the two, and when you graph them, they kind of do this thing. And you want to know when the temperature is over 25 degrees, that's this shaded area here, when does it turn on and when does it turn off? So we're talking about time in hours. So that's one method you can use to solve that, and just use your intersect feature to find out where those two overlap. The other way that you can solve this is using algebra. So what we want to do is we want to solve for t. So we're going to take and... let me just get rid of that. And right. Okay, so we want to know when these equal each other. So 24 minus cosine pi over 12 t equals, we want to know when that equals 25 degrees. So first thing we're going to do is subtract 24. So negative cosine pi over 12 t equals 1. And then we divide by negative 8. Yes, there's supposed to be an 8 in there. Oh, hello. Welcome to the party, 8. Divide by negative 8. Also, if you did it by graphing, you should redo it with that 8 in there. I'll have to edit that later. Okay, so we have cosine pi over 12 times t equals negative 0.125. Now from here, we need to get rid of the cosine, so we need to multiply by cosine inverse. Hopefully you remember how to do that on your calculator. So cosine inverse of negative 0.125. You get pi over 12 t equals some number. I'll just leave it like this so it's prettier. Negative 1.25. And then you're going to multiply by 12 over pi. So take that messy number and multiply by 12 and then divide by pi. And then you should get t equals 6.5. Either way, it'll be 6:30 in the morning. And then if we use process of reciprocity, reciprocals, nope, symmetry, however you want to call it. If it crosses here at 6.5 and you assume that this is high noon, how many hours is it from 6:30 until 12 o'clock? Well, that's another 5.5 hours. So this would be at 5:30 p.m. Alright, so at 6:30 a.m. until 5:30 p.m. is how long your air conditioner runs. Must not be Vegas, because not enough air conditioner running. Okay, here's your lesson check. I want you to do these two questions, and then you're going to compare them with your partner when you get to class. And your homework is lesson 14-2. I hope you have a great night.